Everyone thought Rolls-Royce was finished. After massive layoffs, canceled contracts, and years of silence, the aviation world just, well, stopped watching. Boeing and Airbus were busy fighting over global dominance. GE was showcasing its record-breaking engines. And Rolls-Royce, honestly, was just a name from the past, a legacy brand with no new edge. Or so they thought. Because while the industry moved on, Rolls-Royce went dark for a reason. Behind closed doors they were building something no one expected. Not a minor update, not a concept sketch, but a fully functional prototype of the most advanced jet engine ever created. They call it the UltraFan. And it doesn't just outperform their last generation. It leapfrogs the entire industry. It's bigger, lighter, smarter, more efficient, and more importantly, it's not a theory. It works. It's already been tested successfully. While Boeing scrambled with delays and Airbus doubled down on old tech, Rolls-Royce quietly made a move that could flip the entire aviation hierarchy. Because UltraFan isn't just an engine, it's a turning point. It's designed to run on sustainable fuels. It's compatible with hydrogen and hybrid systems, and it delivers up to 25% better fuel efficiency than anything Rolls-Royce has ever built. Before we dive deeper, make sure to like and subscribe. This engine war is just getting started. The story gets even more interesting because Rolls-Royce didn't just build a smarter engine. They built a direct challenge to the reigning heavyweight, the GE9X. This thing is a monster, 134,000 pounds of thrust. A record-breaking engine made specifically for the Boeing 777X. All muscle, all power. But here's the problem. It's trapped in the past. The GE9X is huge, heavy, and locked into a single aircraft type. Rolls-Royce looked at that and took a different path. They built the UltraFan with modularity in mind. Instead of chasing more thrust, they chased more control. A gearbox that lets the fan and turbine spin at their own perfect speeds. A bypass ratio over 15-1, the highest ever seen in commercial aviation. That alone cuts fuel burn by over 25% compared to the Trent XWB. And unlike GE's one-size-for-one-plane model, the UltraFan is scalable. Same core, different thrust classes. It can power wide bodies, narrow bodies, and future hydrogen-electric aircraft, all with one platform. GE made a statement. Rolls-Royce made a system. So now the industry is facing a choice. More thrust or more future. Because, UltraFan might not be the loudest engine in the sky, but it could be the one flying the longest. And if you're wondering how Rolls-Royce pulled this off, it comes down to engineering precision at every level. Let's start with that massive 140-inch fan. It's actually the largest ever made for a commercial jet engine. But, honestly, size alone isn't what makes it revolutionary. Each blade is forged from carbon composites reinforced with titanium edges. That means it's strong enough to survive a bird strike, but at the same time, light enough to save serious weight. Now combine that with a 15-1 bypass ratio. More air bypasses the engine core, creating more thrust with less fuel. Quieter, cleaner, more efficient. Yeah, that's the sweet spot every engine maker has been chasing. UltraFan got there first. But the real secret? It's the gearbox. It decouples the fan from the turbines, allowing both to spin at their ideal speeds. It's kinda like giving the engine multiple gears and it makes everything more efficient. Inside the core, Rolls-Royce took it even further. Instead of traditional metal alloys, they used ceramic matrix composites. These materials handle insane heat and pressure, letting the engine run hotter, boosting thermal efficiency, and cutting fuel usage even more. And none of this is hypothetical. It's been tested, verified. 64 megawatts of power through the gearbox. A world record. Real numbers. Real performance. UltraFan isn't a prototype. It's a proof of concept that works. And it's all part of something much bigger. Because this engine wasn't built in isolation. It's the result of 4 decades of relentless innovation. UltraFan didn't come out of nowhere. This engine is the product of 4 decades of relentless engineering. Every breakthrough, every failure, every lesson compressed into one machine. Back in the 1970s, Rolls-Royce changed the game with the RB211, introducing the 3-shaft engine design that set the foundation for modern long-haul travel. Then came the Trent series, the 700, the 900, the XWB. Each one powered flagship aircraft like the A330, the A380, and the A350. Each one pushed the limits on efficiency, performance, and emissions. But even the Trent XWB, the most efficient engine in commercial use today, had its limits. Rolls-Royce knew they couldn't just improve on the past, they had to start over. UltraFan is not a Trent evolution, it's a clean sheet design. It's the first time Rolls-Royce used geared architecture in a wide-body class engine. It's the first to integrate ceramic matrix composites in critical hot zones. And it's the first to adopt large-scale 3D printing for structural components, cutting weight, increasing durability, and reducing waste. But here's the part the public doesn't always see. While most people obsess over thrust and size, airlines obsess over numbers, operating costs, maintenance, fuel burn, regulatory penalties. And that's where UltraFan flips the entire equation. This engine cuts fuel consumption by up to 25% compared to the Trent XWB. That's not marketing fluff. That's millions of dollars in savings per plane per year. At a time when jet fuel eats up over 30% of an airline's total expenses, UltraFan isn't just impressive, it's financially irresistible. And it doesn't stop at fuel. UltraFan's modular construction means fewer unique parts and faster turnaround during maintenance. Its cooler operating temps mean less wear on components. It uses predictive analytics to spot potential issues before they happen, avoiding delays, grounding time, and surprise failures. And in the background, the pressure is mounting. Governments aren't asking airlines to reduce emissions anymore, they're mandating it. The EU's Fit for 55 initiative is already penalizing high-emission flights. The International Civil Aviation Organization is setting global caps. Even passengers are choosing flights based on environmental impact. The old jet engines, they were built for an era that's rapidly disappearing. UltraFan is built for what's next. It's ready for 100% sustainable aviation fuel from day one. It's designed with future hydrogen systems in mind, and it's built to evolve, to shift into a hybrid electric role when the time comes. This engine doesn't need to be retrofitted for the future, it's already there. And then there's noise, an invisible cost most people forget. Airports across Europe and Asia are cracking down on sound pollution. Noisy aircraft lose takeoff slots, face fines, or get banned from night operations entirely. UltraFan's high bypass ratio and smart gearbox architecture make it one of the quietest large engines ever tested. That means airlines can operate longer hours in more locations with fewer restrictions, which translates directly to more revenue. So when airlines look at UltraFan, they don't just see a leap in engineering, they see lower fuel bills, fewer delays, reduced carbon taxes, increased flexibility, and better margins. And that's why the industry is paying attention now. Because UltraFan isn't some futuristic prototype, it's the sharpest economic tool airlines have seen in. Traditional jet engines are made using casting, welding, and machining processes that are complex, slow, and heavy. Rolls-Royce flipped the script. UltraFan's critical components, including blades, brackets, and internal supports, are printed using high-strength alloys and composites. This allows for more intricate airflow designs, less material waste, and lighter parts with higher heat tolerance. Even the massive 140-inch fan blades aren't conventional. They're made from carbon composite material, lighter than titanium, but reinforced with titanium leading edges for durability. That combination reduces overall engine weight while increasing strength. A rare win-win in aerospace design. And let's talk about the core, the most extreme environment inside the engine. Here, Rolls-Royce used ceramic matrix composites, or CMCs, a material that can handle temperatures far beyond what metal alloys can tolerate. This means the engine can run hotter, which boosts thermal efficiency and cuts down on fuel use. CMCs are also lighter and more resilient, reducing fatigue over time. And then there's the gearbox, the crown jewel of UltraFan's architecture. It allows the fan to rotate slower while the turbines spin faster, letting each section operate at its optimal speed. This not only reduces fuel burn, but also cuts engine stress and opens the door for modular scalability across aircraft types. But Rolls-Royce didn't just innovate inside the engine. They reimagined how the engine integrates with the aircraft, and for that, they formed a dangerous alliance. Because back in 2018, Rolls-Royce quietly signed a deal with Airbus. The goal to flight test UltraFan as part of a full integration system, not just as a drop-in engine, but as a complete propulsion architecture, engine, pylon, nacelle, all built together, optimized together. This partnership wasn't just a handshake, it was co-funded by the European Union's Clean Sky 2 program, a €1 billion research initiative focused on slashing aviation emissions. Airbus knew what it wanted, a path toward the next generation of long-haul and short-range aircraft built with sustainability baked in, not bolted on. And Rolls-Royce? They wanted their engine flying first on the biggest platforms in Europe. It was a perfect match. Together, they're building integrated power plant systems that go beyond thrust. They're targeting noise, drag, fuel economy, even manufacturing techniques like high-rate thermoplastics and automated welded assemblies that can scale fast. And Boeing? They weren't in the room. GE wasn't either. While Boeing bets everything on the GE9X and its aging partnerships, Airbus and Rolls-Royce are co-developing the future in silence. And speaking of silence, UltraFan has one more advantage that almost no one talks about, but every airport cares about: noise. Jet engine noise has been one of the biggest thorns in the side of the aviation industry for decades. Takeoffs and landings generate the most complaints from communities living near airports, and governments are starting to respond not just with noise fines but with restricted flight slots, curfews, and operational bans. UltraFan was built with this reality in mind. Thanks to its ultra-high bypass ratio, the fan moves more air at lower velocities, which naturally produces less noise. And the gearbox design reduces fan speed even further, especially during takeoff and descent, the noisiest parts of flight. The result? A massive drop in decibels without sacrificing performance. For airlines, this means fewer regulatory headaches. They can operate into noise-sensitive airports, fly at night, and apply for additional flight slots that noisier aircraft are barred from. It's not just about passenger comfort, it's about access, flexibility, and revenue. And for airport authorities, quieter engines make expansion plans easier to approve because ultra-fan-equipped aircraft meet stricter noise targets that old engines simply can't. It's a subtle advantage, but a strategic one. Because as more countries start treating airport noise like pollution, the quietest engines will have the loudest commercial impact. So now you've got a jet engine that's not only powerful and efficient, it's light, it's modular, it's future-ready, and it's quiet. So where does this leave Boeing? In a dangerous spot. Because while Airbus and Rolls-Royce quietly moved toward full integration, Boeing stayed tied to GE and to legacy engine architectures that were optimized for raw power, not future flexibility. The GE9X is undeniably powerful. It's also enormous, tightly coupled to the 777X platform and built with a narrower focus. And here's the issue. The 777X program has been plagued by delays, years behind schedule. Certification pushed back, orders reduced. Meanwhile, UltraFan doesn't just power one plane, it's modular. That's the part few people grasp, but it's the real masterstroke. UltraFan was built to scale same-core architecture, multiple thrust classes. It can be tuned for narrow-body jets, long-haul wide bodies, and even future hybrid electric or hydrogen propulsion systems. It's not one engine, it's an entire ecosystem. And that modular design opens the door to something game-changing: fleet unification. Airlines hate managing multiple engine types, different parts, different crews, different maintenance schedules. It's costly, it's inefficient. UltraFan's adaptability offers a single solution across multiple aircraft models. That means lower training costs, easier logistics, and streamlined service contracts, all of which translate into huge savings over time. And while GE continues to rely on aircraft-specific mega-engines, Rolls-Royce now has something that can move horizontally across the market. It's not just about selling engines anymore, it's about locking in airline ecosystems. And with Airbus already integrating UltraFan into its future roadmap, the writing's on the wall. The next generation of aircraft won't be designed around engines. The engines will be designed with the aircraft from day one. That's the kind of alignment Boeing doesn't currently have. And it's the kind of gap that doesn't just affect one plane, it reshapes global market share. Because what happens when you're an airline looking 5, 10, or 20 years out? You see rising fuel costs, tighter emissions targets, new rules around noise, and aircraft that need to stay in service longer than ever before. Now ask yourself, do you bet on an engine built for the last platform, or one built to evolve with whatever comes next? That's the quiet power of UltraFan. It's not just an engine, it's a platform play. And that brings us to the final point. This wasn't just about building a better turbine, it was about building leverage. Rolls-Royce now holds a key that unlocks flexibility for airlines, performance for passengers, and sustainability for regulators, and they've done it at a time when every piece of the aviation puzzle is being re-evaluated. Post-pandemic economics, environmental pressure, technological acceleration, Ultrafan doesn't just tick the boxes, it shifts the playing field entirely. It turns fuel efficiency into market share, it turns sustainability into a competitive edge, it turns engine design into airline strategy. And maybe most importantly, it forces everyone else to catch up. GE will have to respond, Boeing will have to rethink, the entire engine ecosystem will have to move faster, smarter and leaner. Because Ultrafan isn't just here to compete, it's here to change the rules. So next time you hear someone say Rolls-Royce is just a legacy brand, you'll know better. They didn't just survive, they may have just built the future of flight.